In this video, we're going to be doing integration using long division. Let's start with a quick review of polynomial long division. So let's say I want to divide these two polynomials. We're going to start by putting our numerator under our half a box and our denominator out front. And what we do is we look at the first terms and we say, this term times what gives me this term. In this case, that is going to be x to the third. Then I'm going to take x to the third and I'm going to multiply it by both of these two terms. I'm distributing the x to the third. So we get 2x to the fourth plus 3x cubed. Now I want to subtract 2x to the fourth plus 3x cubed, so I'm going to distribute a negative, and then I'm going to add down. Notice these first terms cancel. 5x cubed minus 3x cubed is 2x cubed. Once you do that, bring down the next term, and you're going to repeat the process. So we're going to say 2x times what gives me 2x cubed. That is going to be x squared. I want to distribute the x squared to 2x plus 3. That's going to be 2x cubed plus 3x squared. We want to subtract, so I'm going to distribute a negative. 2x cubed minus 2x cubed is 0. 7x squared minus 3x squared is 4x squared. Bring down the next term. Then I'm going to say 2x times what gives me 4x squared. That's going to be 2x, so I'm going to put plus 2x at the top. I want to distribute the 2x to the 2x plus 3. That's going to be 4x plus 6x. I want to subtract, so I'm going to distribute a negative. I'm sorry, that's 4x squared plus 6x. Distribute your negative. 4x squared minus 4x squared is 0. 16x minus 6x is 10x. Almost there. Bring down the next term. Then we're going to say 2x times what gives us 10x. That's going to be 5. Do that in blue. Distribute your 5 to 2x plus 3. We get 10x plus 15. I want to subtract, so I'm going to distribute a negative. Notice that this gives me 0. So when I'm at 0, that means I don't have a remainder. So my answer is just going to be what we have at the top. And that's a little review of polynomial long division. Now we're going to do some integration using long division. The general rule is we can do long division if the numerator's degree, so here the degree, oops, let me switch to a pencil. The numerator's degree is 1, denominator's degree is 1. We can do long division when the numerator's degree is greater than or equal to the denominator's degree. So let's do this problem. I'm going to start by doing my long division over on the side. I'm going to say x times what gives me x. That's going to be 1. Distribute your 1 to x plus 1. We get x plus 1. I want to subtract. X minus x is 0, and then I get negative 1. Now, it doesn't really make sense for me to say x times what gives me negative 1. That's going to be like a 1 over x with a negative. So when it ends up being as something over x, that means that we're done with our long division. So we're going to say negative 1 is our remainder. So I'm going to say minus 1 over, and we always put it over whatever's out front right here, x plus 1. So I can rewrite my integral. This is the same thing as 1 minus 1 over x plus 1 dx. And the goal with long division is it might be difficult for me to integrate the original integral, but if I split it into a couple or even a few different integrals, maybe I can tackle each one separately. So let's do that with this one. I'm going to integrate 1 dx minus 1 over x plus 1 dx. For this first integral, when I integrate 1, I get x plus c, but I'm going to put that at the end. For the second one, I am going to be using u sub. U is x plus 1. du is dx, so we don't need to worry about changing anything in the problem. I'm going to get minus, keep in mind that the integral of 1 over u du is the natural log of u plus c. So I'm going to get the natural log of x plus 1 plus c. And that is your answer. Let's do a couple more examples. Here's our next one. Notice that the degree of the numerator is 3 and the degree of the denominator is 2. Because that degree is greater than or equal to the degree of the denominator, we know we can do integration using long division. So let's do our long division. I'm going to say x squared times what gives me 3x cubed. That's going to be 3x. Distribute your 3x to x squared plus 4. That's going to be 3x cubed plus 12x. We're subtracting, so I'm going to distribute a negative. 3x cubed minus 3x cubed is 0. And 2x minus 12x is negative 10x. Bring down the next term. Now notice x squared times what gives us 10x. We're going to start having x's in denominators in order to make that work. So that's how we know that we are done with our long division. Negative 10x plus 5 is our remainder. So I'm going to say plus negative 10x plus 5 over x squared plus 4. So I'm going to rewrite my integral. This is the same thing as 3x plus negative 10x plus 5 over x squared plus 4. I'm going to split this. Now, before I split it, let's do it this way, 3x. And I'm going to split my my fraction into two separate fractions. So I'm going to make this negative 10x over x squared plus 4 plus 5 over x squared plus 4 dx. I'm setting myself up for a u sub here and then an arctangent for the last term. So let's split this into 3 separate integrals. Okay, so for the first one, for the first integral, this is your basic integration rule. Increase your exponent, divide by the exponent, so 3/2 x squared. For the second one, maybe let's move this down a little bit. For the second integral, let's do u sub. Let's make our denominator equal to u. That means our du is 2x dx. So in my integral, I have 10x dx. Notice that that's 5 times 2x. So I do have my du right here, but I am going to have a 5 on the outside of the integral. So I'm going to pull out my 5, and I'm going to have 1 over u du. That is going to be our natural log, so we'll get to that in a minute. For the last one, keep in mind that we have the rule. Let me write it up here. The integral of 1 over u squared plus 1 du is equal to arctangent of u plus c. If you're not sure how to do this, I have a more in-depth video on my channel, but that is what we're going to be using for this last integral. So I'm going to take the 5, I'm going to pull it out front. And then in my identity, notice it's a u squared plus 1. So instead of a 4 here, I want a 1. So I'm going to, in the denominator, factor out a 4. And then I am going to, maybe let's move this a little bit. The second thing to notice is I have an expression squared. This is u squared. And this is not an expression squared. It's an expression squared divided by 4. So I want to rewrite that. I'm going to bring my 4, my 1 over 4 out front. So this is going to be 5/4. And I'm going to rewrite x squared over 4 as x over 2 squared plus 1 dx. From there, we're ready to use u substitution. We're going to make our expression that's squared our u. So u is x over 2. That means du is 1/2 dx. Now right now I just have dx, so I'm going to make this 1/2. If I do that, I need to multiply by 2 somewhere else. So I'm going to do that in front of the integral. So let's write out another line and see where we're at. So I have, let's see, my 2 is going to cancel, and I'm going to have 5/2 1 over u squared plus 1 du. Okay, so let's do our integrals. I have -5 natural log of u. Keep in mind this u is referring to x squared plus 4. And then I have plus 5 over 2. We said that this is our arctangent, so I'm going to copy this. Arctangent, and our u for this one is x over 2. And then don't forget the plus c. So that is our answer to this problem. So again, with the long division, the goal of long division is it's hard for me to integrate this expression how it is, but if I split it up into multiple expressions, maybe I can integrate each term separately, and that is our goal. Let's do one more example. So same thing, notice that the degree of the numerator is greater than or equal to the degree of the denominator. So let's start with our long division. All right, so for this one, x squared times what gives us x cubed? That's going to be x. Distribute the x to the x squared plus 5. We get x cubed plus 5x. I'm going to put that where we have like terms vertically. So I'm going to put the 5x under the 8x. I want to subtract, so I'm going to distribute a negative. X cubed minus x cubed is 0. I'm going to bring down the 3x squared. 3x squared plus 0 is 3x squared. 8x minus 5x is 3x. Okay, from there, x squared times what gives us 3x squared? That's going to be 3. I'm going to distribute the 3. I get 3x squared plus 15. So 15 is like terms with the 19. So I'm actually going to bring down the 19 also. I'm subtracting, so I want to distribute a negative. 3x squared minus 3x squared is 0. 3x plus 0x is 3x. 19 minus 15 is 4. At this step, notice if I ask myself x squared times what gives me 3x, I'm going to have x's in a denominator. Again, that's how we know that we are done with long division. So 3x plus 4 is your remainder. I'm going to say plus 3x plus 4 over x squared plus 5. Okay, so let's rewrite our integral. And just like we did before, I'm going to split this 3x plus 4 over x squared plus 5 into two separate fractions because we're going to want to integrate those separately. So I'm going to say, let's just split up our integral, x dx plus 3dx plus 3x over x squared plus 5 dx plus 4 over x squared plus 5 dx. Okay, so we've got 4 integrals to do, but we can do each of them separately. The first two are pretty simple. I have 1/2 x squared. We're going to put our plus c at the very end, so don't worry about it for right now. The integral of 3 is going to be 3x. For the third integral, I'm going to be doing u sub. I'm going to make u x squared plus 5. du is 2x dx. Right now I have a 3x, so I'm going to bring the 3 out front and then also multiply by a 2. If I multiply by a 2, then I need to multiply by a 1/2 out front. So out front, I'm going to have the 3 that I pulled out times the 1/2. So that's going to be 3/2. And then for my integral, I'm going to write it in terms of u. I'm going to have 1/u du. For the second one, we're going to do the same thing we did before. This is going to be an arctangent integral. So I'm going to bring the 4 out front. I want this term, this 5, to be a 1. So I'm going to have 1 over, bring out the 5. This is going to be x squared over 5 plus 1 dx. For the next line, I'm just going to write what I have. And we might as well do this integral. This is going to be natural log of x squared plus 5. Okay, I'm going to bring out this 5 in the denominator. This is going to be 4/5. And then I have 1 over, I want to make this fraction, I want to make sure it's an expression squared. So we're going to have x over rad 5 squared plus 1 dx. Now we are ready for u substitution for this last integral. We're going to make u equal to x over rad 5. That means du is going to be 1 over rad 5 dx. I don't have a 1 over rad 5, so I'm going to write 1 over rad 5. If I multiply by 1 over rad 5, I have to multiply by rad 5 somewhere else, so I'm going to do that out front. Next line, I'm just going to copy the beginning few terms that I have. All right, and then out front of my last integral, I'm going to have 4 rad 5 over 5. And we can probably skip this step, but in case we need it, this is 1 over u squared plus 1 du. And write it out one more time. When I do my integral, this is going to be arctangent of my u is x over rad 5, and then don't forget your plus c. And that is the answer to this problem. Okay, so those are a few examples of integration using long division. Thank you for watching.